Hi everybody, welcome back. This will be part 2, I think, of the question and answer video where I give my answers. I'm pleased to say that the construction downstairs is complete. The workers have moved out, and now we're in the process of just getting things cleaned up and kind of put back together and everything put into place. I'm really looking forward to getting back down to the bench. So hopefully in the next video, hopefully, fingers crossed, we'll be down there. So let's continue with the question and answer as I adjust my camera here. And I'm just going to kind of pick up where I left off last week. So, all right. Hi, Tony, not a question as such, more of an idea for a project learning exercise. I, like many other hobbyists, can't afford the expensive pieces of test equipment. Yeah, I get that. How about a DIY project on a distortion analyzer, something that can generate accurate low noise test frequencies and accept the signal back into what I assume would be a filter network before outputting the signal to a scope? All right, that's a pretty good question. Good suggestion. So if you go back, it's looking like it's about 8 months ago. I'm looking at my channel here. I was in the middle of the Sansui CA2000 preamp project, and I did a little side video, and I built this little device called a difference amplifier. And really all it is an op amp that's used as kind of a comparator circuit. It kind of outputs the difference between two signals at the input. And the whole idea of that is you can feed a known signal into your amplifier, for instance, and then you can, and that goes into the one channel, and then the other channel of the difference amplifier, you connect to the output of whatever it is you're testing. So you're comparing the input to the output. And the whole idea is any difference that you see between the two signals will show up as a waveform. So in a way, it's actually a better way of displaying distortion. So I went through and we did that, and it actually worked really well. And if you go back and look at that video, I think it's called Sansui, let me see if I can find it again here. Where did it go? Sansui CA2000, testing the preamp using a difference amplifier circuit. And then the one after that was called Sansui CA2000, more difference amplifier tests. And they were done about 8 months ago from the posting of this video. So you go back several videos, you'll see it. And that is actually a very effective way to see how an amplifier performs. And then I also went ahead and built a pink noise generator where you can actually monitor the pink noise signal as using that as a test signal, which I think in some ways is better than just a static single sine wave. And the test worked out really well. So that would be a suggestion right there of something that I already did. Now, to take it the next step further and put on a filtering circuit and then have a really low noise sine wave generator, that's a little bit extra work, but I'm sure we could do something like that. And maybe I'll play with that someday. We'll see. Okay, the next question. Hi, Tony. Have you ever been zapped while working on an X-ray machine? Well, I figured sooner or later somebody would ask that. Have I ever been zapped? Well, it's kind of hard to work in electronics and never experience the feeling of electricity flowing through your body. Believe it or not, in the 36 years I've been in the field, really there's only been 2 or 3 times that I've actually been shocked. I mean, sometimes you get across the low voltage power supply and you get a little tingle that really doesn't do anything. But really an actual where it bites you good, I can think of 3 occasions in the past where it's happened. One time I was working on a Siemens fluoro system, and it was a big one. It was a big unit, ran on 3-phase 480 volt power, and entirely my fault. the system was done in modules, and it was fed from a main power source, and I had thought that I had cut that power source, but there was actually another voltage source for the three-phase that was used to create a 24-hour power. And that's kind of the thing that keeps the CPUs awake enough that when you hit the power button, it knows to turn on, because it doesn't use a physical power switch. It actually just used a blister switch on the control panel. And one of the modules had a 24-hour power supply, and it derived it from the three-phase signal. They had three big ceramic resistors that were kind of current limiting resistors, because this thing draws very minimal current, but it does draw it from the 480 volt three-phase. And one of the resistors had gone bad. And as a result, there were some things that were not coming up in the correct sequence. So the machine had a soft start power supply on it that would soft start the capacitor bank, because it had great big huge power supply. And long story short, since that resistor was bad, things weren't working right. I needed to replace it. So I reached into the cabinet, and these resistors are clear in the back of the cabinet. So you had to reach all the way in, and it was down clear by the floor, mounted to a plate. They were chassis mount resistors. And I got between two of the leads, and I got 480 volts in me. And it backed me up pretty quick. I hit the, flew back, kind of hit the wall, and guy that was there with me, he's like, "What happened?" I'm like, "I just got electrocuted." And it hurt, but it was only on the one hand. It didn't go through my body. And that's because of the way I've just trained myself over the years. You never, if you're working with anything, even if you don't think there's power present, you try to put yourself in a position where your body is not going to contact at 2 points where it will cause a path through, especially across your heart. And that's what kind of helped me. Now, would it have electrocuted me if I would have gotten across it with both hands? Maybe, maybe not. I mean, I think the way I was in there, I would have got bit really hard. It would have been a lot more intense, and I probably it would have hurt a lot more. I think I would have still got off of it because I wasn't actually grasping anything at the time. So that was one time. Another time I was working on another system, replacing an X-ray tube, and again, it was a kind of a design where the X-ray portion was all powered down. There was no power, disconnected, but there was another power line that fed the anode circuit that spins the anode. X-ray tubes have a rotating anode in them, so there's kind of like a motor that they use, motor winding. And strangely enough, even though there was no power turning the rotor or anything, there was 230 volts present there. And I got across that. I got across that one pretty good because I grabbed hold of it. Again, reflex, I let go. I didn't grab on, which is a good thing. That bit me a little bit. I jumped. And of course, the guy that was with me kind of like, "What'd you do?" And I'm like, "I got electrocuted." And then the last time was I was working in an OR on a system, and the machine would not make an exposure. So we shut everything down after trying to use it. It would act like it was making an exposure, but there was no X-ray. And obviously no high voltage, right? Well, actually there was high voltage, but the X-ray tube filament circuit wasn't working right. And long story short, high voltage cables are like coax. They have a thin center conductor, a real thick rubber insulation, and then they have a shield on the outside. And they make really good capacitors, especially when the cables are long that go up through the ceiling and so forth. They can be up to 50 to 75 feet long, and they can store quite a charge. Well, this one did store quite a charge. It probably had about 58 to 60 kilovolts on it. And when I pulled the high tension cable up out of the well, just a nice blue spark about that far jumped right out of that cable and went right into the side of my thumb. And that hurt. That was that kind of like a needle going in there, you know. But it was so fast, it just, you know, the capacitance of the cable it let go so quickly. It doesn't hold a lot of joules of energy. It just holds high potential, you know. So those are the three that I can think of where I got bit. None of them were fatal. None of them injured me. One of my friends who was older than me got himself across a 480 line once, and he had a metal watch band on it. He was reaching inside behind. It was an old Litton Profex X-ray machine it was built in the 60s or 70s. It was an old unit. And his watch band got across the 480, and it immediately welded to it, turned, you know, red hot, burned his wrist severely, third-degree burns. Luckily, he was in a hospital when it happened. They rushed him directly to the OR or to the emergency room and began treatment immediately. And they saved his arm and everything, but he was very badly scarred for a long time. He had to have surgery and all kinds of things. And he made a full recovery. His hand is fully functional, but that was a serious injury. And I had another person that I did not know that was a colleague of one of my other engineers. He was an older guy, and he actually got the full high tension through his hand, and it came out his elbow, and it actually blew his whole elbow out. There was an actual hole, and destroyed his arm. I mean, he needed reconstructive surgery and everything, so that was really bad. So working with high tension and working with X-ray machines is no joke. Everybody worries about the radiation, but man, the high voltage and high current that's in there, the potential between the anode and cathode can be up to 150 kilovolts, 150,000 volts. And some of the bigger machines can deliver up to 1 amp of current at 100 kilovolts. There were actually a couple that were even higher than that. There were 200 kilowatt generators. That's very rare, but some of the cath labs out there actually had that back in the day. They're no joke. And they're not really designed for safety. I mean, they do have a lot of safety interlocks and things, but they're designed for you to be trained on it before you work on it. So if you're going to play with that sort of thing, you need to understand that you're taking your life into your hands if you don't understand how that works and don't have proper training. So that's it about being zapped. Okay, next one. How long have you been doing electronics, and what got you interested? And also, where do you find all of this old lab equipment? Well, the old lab equipment, I find it from friends that I have that no longer want to use it. They give it to me. I find them online. I've actually bought some really nice signal generators and things at swap meets, at flea markets, at antique stores. People look at it as an antique for display or something, you know, steampunk, but it's an actual piece of test equipment. And if it's in good condition and it's cheap and people don't know what it is, you know, I'll get them. My friend Dave, who I talk about all the time, he's very, very good at finding that stuff. He's really into collecting and so forth, so he knows a lot of people and is tied in with a lot of things. And he's found me some, like the PA81 and the SG80 and those things. He found those for me, and they were in fantastic condition, and we got good pricing on them. And so that's where I get that. As far as how I got into this, well, how does anybody get into electronics, you know? I think one of the mistakes that people make today in engineering is they look at the statistics that engineers are the most higher employable people or whatever, or you make lots of money if you're an engineer, and they decide, I want to be an engineer. And that's why there's such a high percentage of engineers that graduate and don't get a job in their field, or get a job that they didn't need the engineering degree to get it in the first place. Being an engineer is something I believe you're born with. One of my employees he's beyond retirement age, but he loves what he does and he still works for me, and we've been together for 20-some years working together, put it the best way. He said, you know, you can tell who the engineers are going to be. He says, when I was a kid, you know, my friends would get their toys for their birthday or Christmas or whatever, and they would immediately play with their toys, you know. What what does the average child do? They play with their toys when they get them, right? They're all excited. And he's like, but I was the one that went down the basement and took my toy apart to see what makes it work. You're an engineer by design. And it just so happens you might go to college to get the degree and everything, but you're going to persevere in that whether you go to college or not, because it's so ingrained in you. You're so impassioned about it. You know, tell you a quick story about my history. Like when I was a little kid, I was probably about 6 years old, I saw this toy machine gun in the store. And really, other than playing cowboys and Indians and army, you know, as all the other, with my neighbor kids, you know, guns were just like a thing. They were there, you know, I didn't really think about it, you know, it wasn't, but I wanted this gun. And my mother approached my dad and said, should we be worried about this? Why is he so obsessive about a gun all of a sudden? You know, what's he trying to portray? What's going on in his mind, you know? And my dad's like, I don't know, he's a kid, he wants to play, let him go. And, you know, my mother relented, and we went to the store and we bought this toy machine gun. I took it home. I immediately went down in the basement. I found my dad's hacksaw, and I cut the barrel right off of it and look inside to see what makes that noise, because it was one of those gyroscopic motors. You know, when you pull the trigger, it would spin this little weight. And there was this little clacker that would clack on this little plastic drum and make that rat-tat-tat-tat, you know, shooting sound. I wanted to know what made it work. Once I tore it apart and saw what made it work, I never played with it. You know, my mother told that story a lot of times about me, you know, growing up. You know, and my dad said, see, I told you, you know, he wasn't ever worried about it. But that's what an engineer is, you know. And I had people to inspire me. You know, I have two cousins, one of them 17 years older than me, and the other one is 30 years older than me, and both of them were the same way. They did the same thing, you know, and they both have had very successful careers in electronics, and I kind of grew up at their knee. And luckily, that, you know, because there was no internet back then, and 4 books in my local library, once you read those, there's not much you can go beyond there other than tearing things apart. My dad would buy me radios and things at the flea market. It was $1 or something. If I destroyed it, he's out $1. He didn't care, but the education I got was priceless. That's how I got into it. I would have been an engineer whether I went to school or not, you know, and that's how I got into it, just because it's what I always wanted. Okay, I have several questions about how to align tuners, especially like in stereo high fidelity receivers and things. And really, to do that would be a whole video in and of itself. And I actually have done multiple tuner alignment videos. I did one with that Marantz tuner. I'm trying to flip through here my old videos and see if I can find which one it was. I'm sure some of you are already yelling at the monitor because you remember it, but I did one where I used 3 different types of test equipment. You know, I used the Sencor SG 165, the HP 8657 or whatever the heck, you know, that, and the Sound Technologies ST1000A, and I also used the SG80 Sencor. And I kind of showed all of those, how different methods for connecting it and doing the alignment and so forth. So go back and check out that video. I'm trying to find it. It was quite a while ago that I did it. There's one from 3 years ago called FM Alignment featuring the Marantz 2130. It is a 2-hour and 4-minute long how to align a tuner video. I also did a very detailed demonstration using a spectrum analyzer and so forth with a tracking generator on a Hallicrafters. Was it like a S120 or S100 or SX100, something like that. And you can check that out as well. So again, those are two really good videos if you want to really get into the weeds on how that all works. And pretty much every tuner video I do, I explain something different, that I haven't explained before on another video. So you go through there, there's enough material I think I already have. All right. Hi Tony, I'm always interested how you go about choosing transistors when replacing the old ones that are no longer available. What are the specific details you are looking for, and what's your process? So, and then it goes on, but basically that's what he's asking for. And choosing transistors is very difficult if you don't understand how a transistor works and how the different specs on a transistor affect things. Remember, the main thing is a transistor is a current-controlled device. In other words, the amount of current that you cause to flow between the base and the emitter is going to directly control the amount of current that will flow from the emitter, or from the collector to the emitter. And that's your first and foremost thing. The gain is the ratio of how much base current versus how much collector current you're going to get between the two. And while the gain might be a big deal in some factors, it's not so much a big deal in others. The other thing you have to remember is watts. I think people get caught up with wattage. What is the maximum wattage of that transistor? A 100-watt transistor doesn't mean you can use the one transistor and make a 100-watt amplifier out of it. When they're talking about wattage, they're talking about the amount of heat that that transistor die can handle before it fails. And so it doesn't really matter what the voltage and the current is, although there are voltage and current limits in the transistor as well that will cause problems. But from just a strict standpoint of wattage, any combination of volts and amps that you're applying to that will exceed that wattage of heat will cause the transistor to overheat and fail. So again, you want to make sure that the transistor can dissipate the amount of heat. Transistors dissipate heat in different ways. Some of them don't have any external way other than through the air to dissipate. So like a small signal transistor is just a little plastic case, and it dissipates heat into the air, whereas big power transistors will have a metal tab on them, and you can actually attach them to a heat sink to dissipate the heat. And you have to watch that, because if you're going with a different type of transistor, you have to make sure that even though the wattage may exceed or meet the same thing that you're trying to replace, it has to be able to dissipate that heat the way that it was intended for it to make that spec. So again, if a transistor's in a different case style or something, make sure that it can dissipate that heat in the same manner as the one that you're replacing. The other thing is frequency. When you're dealing with DC electronics, you really don't care about things like transition frequency and so forth, because everything's running at DC. But when you have something where you have frequency, something's operating on AC, the frequency becomes a big factor, because a transistor takes time to turn on and turn off, and that's called the slew rate. And that on and off time also will indicate how high of a frequency it can operate, because if the transistor is still trying to turn on and the signal's already going away, going the opposite direction, the transistor isn't even turned on and you're trying to turn it off already, and vice versa. And then that causes the transistor to lose gain, because it's not totally conducting before you're turning it off already. And that's why as you increase the frequency going through that transistor, its gain will decrease. And that's the point at which the transistor can no longer switch at all, because the frequency is too high. So basically, the input and the output are the same, okay? That's called unity gain. That's that is called the transition frequency, the frequency at which the transistor has a gain of 1, no gain at all, basically. And then anything below that is negative gain. In other words, the transistor is not even turning on at all, or just barely, and it's actually attenuating the input signal instead of amplifying it. So you want to make sure that the transistor can operate in that thing. You can quite often tell that by the circuit you're using. I mean, if you're using it in a stereo amplifier, an audio amplifier, you know that it has to operate in that audio frequency range of 20 hertz to 20 kilohertz, and then you want to give that extra leeway for the harmonics and things, so you want it to be able to at least operate, let's say 100 kilohertz. Almost every transistor in existence today will operate in those frequency ranges, so that's not a problem. When you're choosing a replacement transistor in a tuner, though, for instance, like FM is in the VHF band, and it's going to operate up to 108 megahertz, and then if you add the 10.7 megahertz to that, for the IF offset, you're let's say 120 megahertz you have to operate at, okay? And so if a transistor is not stable up to 120 megahertz and you're using it in the RF front end of that tuner, it's not going to work. Whereas when you're using it in the IF stage, that's 10.7 megahertz, so it's a lot lower frequency. So that's why you'll see things like JFETs and things at the front end of a tuner. But if it does have a transistor, same thing with television, it has to be able to operate in that frequency range and still have some appreciable amount of gain. Because remember, the idea of a front end of preamp is to boost that amplitude, If the transistor doesn't have any gain, it's not going to do you much good, right? So as you're seeing, I'm not looking at the transistor that you're using and putting it up against a chart and comparing it. There are charts that do that. You have crossover manuals and things. But if you don't know what that is, look at the application, look at the specs of the transistor you're going to choose, and look at the availability of what you have. I mean, you can go into Mauser and DigiKey and places like that, and you can actually do a filtered search where you can actually filter it by these different characteristics, and you can drill down to what's available. And what you'll find is there will always be something that'll probably work, but it might be in a different package, it may have a different pin out, and you may have to overcome those challenges. Well, that's just something that's part of it. You just have to figure out how you're going to do that. And each case is, specific. So, but it's all the same process. All right, here's a good one. I'm thinking strongly of making a cost-effective audio dummy load using heating wire. What are your thoughts? Actually, I've considered that, like getting a space heater that has the nichrome wire that it uses for, for heat dissipation. Now that I would not use for an audio dummy load. It would work, but the problem is, as those things heat up, they change in resistance. You want to have a constant load. In other words, if you want to put an 8 ohm load on the amp, you want it to be 8 ohms always. The problem with those nichrome wire heating elements is as they heat up, the resistance goes up, and they change resistance. And so your load will change. If it's a PTC or whatever, those little PTC modules, those will go up in resistance. And the whole idea of it is you want it to stay constant. Now, I thought of using those, though, for like what you would use a dim bulb tester, as a current limiter, because those are going to do just like what the filament of the light bulb does, only on a bigger scale, because those ones you could put high current through them and they would limit the current at a much higher level than a light bulb. Because really, the only practical limits of the dim bulb tester is the maximum current of the bulb. In most cases, a 100-watt bulb is more than enough. But sometimes you want to limit the current, but you don't want to limit it so much that the amp can't run at its full energy. So you see people putting these gigantic 300 or 500-watt light bulbs. Those are hard to get now, and they're expensive. And that would be a good alternative to it. So it would be good, I think, for kind of like a current limiting test jig, you know, like a dim bulb substitute, not for a speaker load though. Okay, do you recommend cleaning all potentiometers in a piece of old equipment or just the ones that sound dirty? Well, if there's any chance at all that they could fail or that there's dirt in them, even no matter, I don't care what they sound like, I would clean them. But there are caveats to cleaning potentiometers. Most potentiometers, especially the really good ones in higher end gear, they will have a type of damping grease. It's like sticky grease that they specifically will put at different places on where the shaft goes through the bushing, and on the back of the pot case itself, they'll put this grease, and that gives it that nice, smooth, kind of damped feel, you know. As soon as you clean that, you wash all that stuff out, and then it's like real floppy. That can also cause the actual wiper element to be a little bit loose, because now, you know, that grease actually kind of stabilizes things. So sometimes that can cause some issues. That being said, if the pot has an open frame, in other words, you can see inside and you can see the resistive element in it and everything, chances are it probably has picked up some corrosion and some tarnish, especially on the wiper ring, you know, that the wiper goes on in the middle as it to connect the center pin of the pot to the wiper, to the, you know, to the resistive element. Those, you know, if they get tarnished, it will eventually, if it's not already giving you trouble, it will give you troubles. If the pot is, if you're able to remove it completely from the circuit and disassemble it and clean it the right way, I showed you on that real controversial, you know, deoxit embalming video. That's the best way to do it, because now you can see the dirt, you can see where it is, you can see that you've properly cleaned it, and then you can reapply any of that grease or anything that was there before to make it as close to original as possible before you reassemble it. So that's a good, best way to do it. The spray and pray method, well, it works, of course. You can just hose it out and hope that it cleans everything out, and it'll buy you some time, but the problem will probably come back if you don't get everything properly cleaned out. The other thing on that video that I did a long time ago, I think that was one of my most watched videos. I never said that deoxit will eat carbon. What I said is that it will damage the pot in some cases. Some older pots use that formica stuff as a substrate to mount the carbon onto. And what happens is, when you put any kind of oily substance that soaks into that, sometimes, depending on the type that they used, especially the really early ones from the 30s and stuff, it will actually cause them to get kind of, it's like if you take fiberboard and you soak it with oil or something, that fiberboard will get kind of mushy and it'll start to break down. I did a video on a really nice Hallicrafters SX42 or 43, or no, SX42. And I showed an instance where someone had really sprayed the selector switch, and it has that same kind of fiberboard, and it just crumbled. Like I could take my fingers and just break pieces off because it was so soaked with that stuff. You know, it wasn't the fault of the deoxit, it was the fault of the people applying it, putting too much of it and using it in a place that they probably shouldn't. You don't need that to be in the fiberboard. You need it to be on the contacts themselves. The other thing is the red deoxit is more made for metal surfaces like switch contacts, and the green deoxit is a slightly different variant that works better with, you know, with the carbon track and stuff. That's why it's called fader lube, because, you know, fader sliders and so forth, it actually causes some gives you the lubrication, but it also doesn't interfere as much with the carbon element. You got to understand, if you put the wrong stuff on there, it'll work for a while, but it will interact with moisture or with dirt and things, and it'll actually, the problem will come back worse later on. And that's what I meant by that video. So no, carbon is one of the last things that will be in the universe at the end of the universe. So it's not going to be destroyed by spraying it with some cleaner. That being said, the binding agents that they use to form those carbon traces, they usually will take a powdered amalgam of carbon and they'll mix it with a binding agent and they'll form it, and then when it cures, it makes that little trace, and then they rivet that onto that backboard. And sometimes some of these cleaning chemicals will cause that to break down, and you can actually kind of see when you're rubbing on that carbon, you can actually watch it smear off onto your fingers, and it's not dirt, it's actually the carbon after a while. I've seen that happen, and you'll just see that trace in there, and there'll be like little pieces of it that'll be real thin, you know, from wearing down, and that's what I'm talking about. So again, that's about my thoughts on cleaning potentiometers. Okay, again, on this video, I'm not going to be able to answer all the questions. I still have this many to go. So I've seen several techs test electrolytic capacitors in circuit with no power with a DMM to determine the failures. What procedure should one do? Ohm, diode tests, whatever, and what results would show failures? Well, really, a digital multimeter is not a really good in-circuit capacitor tester for electrolytics. You can check an electrolytic for a short by just putting it on ohms and going across the capacitor. And you'll see it'll charge up with your meter, which will take forever because your meter's high impedance. But if it's dead shorted, it'll just go to 0 ohms or whatever, show a short. Beyond that, the meter does have a capacitance meter, you know, where it can measure capacitance, but really you have to be out of circuit for that to work. If there's things in the circuit with the capacitor, your capacitor meter on your DMM is not going to work accurately. Now, I think what you see other people using is an ESR meter, or equivalent series resistance meter. It's a special kind of resistance meter, and what it does is it applies a very high frequency signal of 100 kilohertz. And that 100 kilohertz signal tends to get around a lot of things like resistors and transistors and things like that. And it will allow you to test an actual signal passing through that capacitor. And if the capacitor is working properly, the capacitor at very high frequencies like that will kind of act almost like a short. It'll pass the signal through. And the leakier, or I shouldn't say the leakier, the higher the ESR of the capacitor, the more resistance it will show up as. It's not really a resistor, but it's attenuating that signal, you know. And those you can use in circuit, once again, like I said, because most of the things that you're going to test, for instance, if you test a 1K resistor with an ESR meter, the ESR meter is not going to read much of anything because it's designed to look at low resistance. But if you put a capacitor in parallel to that 1K resistor, the capacitor will read really low because it's passing the signal through. And so those are good in-circuit things. But I've proven time and again, though, that ESR isn't the only way to test an electrolytic capacitors. An electrolytic capacitor, if it's shorted, it'll show as a good capacitor on an ESR meter because you'll say, wow, this thing has really low ESR. Well, no, it's not low ESR. It's shorted, or it's almost shorted. So, you know, it gives you a good idea of how a capacitor is working, especially like some of them you could see if you have like around 1 ohm or just slightly less than 1 ohm, that's showing the ESR. And depending on the cap and how many microfarads it is, like if it's a 10 microfarad or 2 microfarad cap, that would be a good ESR, and that would be a good capacitor. And it's not shorted because it's not reading 0 ohms, it's reading, you know, a little bit under 1 ohm. It's reading milliohms. So that's one in-circuit test, but anything else, you pretty much have to take the cap out to test it. Unfortunately, it's just the way they work. Have you found any good electronic surplus outlets? I have found many of them over the years, most of which are now closed. There is one that I think is still around. I haven't bought anything from them in a while, and it's not far from where I live. It's driving distance. It's called Electronic Surplus, and it's based in Cleveland, Ohio, here in the States. They do have a website, and I think it's just called Electronic Surplus or something like that, .com. But if you Google search it, you know, Electronic Surplus, Cleveland, Ohio, they were still in existence. The only thing is they don't have counter service anymore. You have to order online, because back when I started in X-ray, I started out in Cleveland. I actually lived there when I was training and so forth. And we used to go there because one of the big X-ray manufacturers for the world, Picker X-ray back then, their factory was in Cleveland, and a lot of times when they finished a production run on things, they'd sell off all their surplus parts that they don't use anymore, that are obsolete, and they would go to that Electronic Surplus, and we'd go in there. As like a candy store. We bought Tektronix lab grade, you know, equipment there, oscilloscopes and signal generators and meters and all kinds of crazy stuff that laboratory things. I've never seen a 55-gallon drum of 1N4007 diodes until I went there one day. And they literally had a 55-gallon drum. How many would fit in there? A million, I don't know, hundreds of thousands anyway. And they were selling them by, like, you know, the bag full. You could just grab a handful, put them in a bag, and they'd charge you like $10 or something for it, or whatever. Transistors, all kinds of things. They still exist. I don't think they have the inventory they used to, and you have to order online, but they have some things. Surplus Sales of Nebraska is a big one. If you're looking for strange semiconductors and things like that, you know, parts, resistors, different things, a lot of times they'll have things there. They do sell out a lot. Everybody knows about Surplus Sales of Nebraska, so a lot of the really good stuff sells out really quickly when they get it. But that's another good source for that kind of thing. But there's several of them out there, and I've used them, and they're actually really good. Sometimes that's the only source you have for a, you know, very in demand and out of production old part. So those are a couple of them, though. All right, Happy New Year, Tony. I watch all your videos and enjoy them. I've often wondered which repair restoration was your favorite. Maybe there's more than one. Well, there is more than one, but there are some that definitely stand out more than the others. I really enjoyed doing the Sansui AUX1. The result when it was finished was just astounding. I just couldn't believe how that amp performed. And I should have named that one when you asked me for my favorite integrated amp. That's one of them. I just didn't think of it at the time. That was a really fun restoration. I really enjoyed doing the Pioneer SX1980 and the Marantz 2500, because just they were big, you know, really impressive, and both of them had so many problems. And I liked them so much that maybe you might see something in the future here on those, but I'll leave it at that. But those were definitely a lot of fun to do. I liked doing the CTF 1250 tape deck Pioneer just because it was something different, and I learned a lot, and there was a lot of fun things I got to do that I don't normally do with amplifiers and so forth, so that was a good one. I really had a good time with the Booty Fad Blabs amplifier project because we all learned things together as we went, and you saw this cheap $10 Chinese amplifier board actually turn into a really well-performing amplifier. That was a lot of fun. And I liked that push-pull 6BQ5 amplifier project that actually DIY Audio has looks like they have a thread on it that a lot of people went out and bought that kit after I did that project, and they've improved the kit since I bought it. People have found little errors in what I did, and they've corrected those, and it's really grown as a project. So if you go on to DIYaudio.com, you can look up that thread. So that was fun. Wow, there's just quite a few of them. I like them all. Even like I would never do another one, but the Pioneer, what was it, that tuner, what was it, the F28. There's the 28, and then there was the 26, was just, that one worked. I have another 26, by the way, we're going to look at later. But that was a lot of fun, too, the F28, kind of figuring out how that thing worked, because it's so different from any other tuner I've ever worked on. And really early synthesized tuning. So that was a lot of fun. That was it. Yeah, there was quite a few. I just enjoyed it working on. How many pets do you currently own? Well, unfortunately, I own 0 pets now. Just 2 months ago, Mango, our cat, was diagnosed with very, very advanced cancer. We didn't know, and she only lasted a couple more weeks after that. So we do not have a pet right now. Of course, we had Mango, we had Bella, and you've all seen her, and Cookie. I think you saw her in a really early video. But yeah, they're all gone now. So, and Barb and I don't have time to raise another pet. So we're probably not going to get one anytime soon. So we'll just have to babysit our kids' pets when they get them. How do you deal with germanium transistors when they become impossible to find for replacement? That's a really good one. You only have 2 choices today. Number one, you can still purchase germanium transistors, certain types of them, from Russia and Ukraine and so forth. They continued manufacturing them a lot longer than they did over here in the States and over in Europe. So you can still get them. There's a pretty good supply still available, but you really have to really look at the specs. It's really not easy to understand, and it's hard to get specs for the ones that you're trying to replace it with and all that. So that's kind of a challenge. The other option is to modify the circuit to work with silicon transistors. You have to change the biasing and so forth. And if you understand how a transistor works, it's not super difficult. You don't really have to worry about thermal runaway. So the thermistors and things that they used for those, really, you can leave them in the circuit, but they're not going to be much of it needed, with the silicon transistors. Some you can drop in and replace, like the Seeberg jukebox amplifiers. A lot of those, you can drop in a silicon transistor in place of the old germaniums, and it just works. It just works, My cousin's done it many, many times, and he never had to modify anything, he said. I've watched him do it, and it does work. So very circuit dependent, but sometimes it's as simple as just replacing it with a similar silicon one, and with similar voltage and current and wattage ratings, or make a slight change to the bias and it will work. Because you got to remember the forward voltage drop is different. On a germanium it's about 300 millivolts, and on a silicon it's going to be around 600, 650 millivolts. And that's going to affect the forward current gain and so forth quite a bit. So you just want to compensate for that. The other thing is the germaniums will change a lot more radically with temperature than a silicon. But again, that's why they put those thermistors and things in there to counteract that. And you won't really need that with the silicon transistors. But if you leave it in there, it won't hurt anything, because that transistor is not going to really drift a whole lot. As much, I should say. They all drift, but not as much as germanium. Hope that helps. Okay, I have two more that I'm going to end with here, and then we'll wrap this one up. The first one is, I get a lot of questions, and it's not just on my Ask Tony a Question video, but almost many of my videos. Tony, can you repair my fill in the blank? And even though I put a disclaimer at the front of all my videos, or most of my videos, stating that I don't take outside work, I still get that question asked a lot. It's not because I don't want to help you guys out, but it's that I do not have the time. I still have a full-time business. I still have lots and lots of projects of my own to do to keep me busy. And really the only time I do this is when I'm making videos. So I just don't have the time. The other issue is shipping things back and forth. I've had terrible experiences with that. No matter how well you pack something, it's going to show up on the other end a lot of times with damage. And, for you to ship your really heavy, really valuable, really rare, really expensive piece of audio gear to me, and it shows up and the dial glass is cracked, or a knob is bent or broken, just too much hassle. And then on top of that, if I make a repair and it's working and it sits on the bench for a week and everything's good, and I pack it up and ship it and you get it, and then 2 months later another transistor or something fails that either I missed or that just failed because it's an old receiver. Gee, Tony, you fixed this and now it's broke again. It only lasted 2 months or whatever. It's vintage audio. You can try to, and there's always a trade-off. Do you want to spend exorbitant money and time replacing every little meticulous thing in there in the hopes that you get everything that can fail replaced with new? Or do you save a little bit of money and leave some of the vintage stuff in there? Some people don't want to change any more than they have to because they don't want to affect the tone, the original vintage sound. Just not worth my time. So that's why I don't do it, really. Some special friends, some of you that are patrons who have asked, and under the right conditions, I will help them out. But that's about the limit of it. Okay, I'll read off the last one because I think it's kind of fitting as the last question for this video. Tony, I wish you all peace, joy, happiness, and good health in your lives. The way you finish your videos is very touching. Well, thank you. Was this a phrase you created? Was this something you heard from someone you admire? Thank you very much. So, where did that come from? Well, it was a long time ago at the end of one of my videos. I was just basically closing the video, and that's what came to mind to say to all of you, and I kind of liked it when I said it. Really, the first two things, peace and joy, those are choices we make in our life, right? We can choose to have those things in our life. We can choose to live our lives with those things. And the other two things are things that maybe are out of our control. They come and go, happiness and good health, but those two things help us along with those first two things that we choose. So, I basically said it, and I'm like, yeah, that makes sense, And I've just been closing my videos with that ever since, because that's what I meant at the time I said it, and I still mean it every time I say it. It makes sense to me. So hopefully if those things do come upon all of you, man, what a better place this could be for all of us, right? So, peace, joy, happiness, and good health in your lives. And I will see you all on the next video, and hopefully we'll be sitting at the bench and we'll be able to finish. I'm just going to do maybe one. I might do one more. I might not right away, because I still have that quadraphonic system set up on the bench ready to do some really cool stuff with. So I might do that. I might do one more quick question video because there's still quite a few I haven't done yet. We'll see. Until then, though, take care, everybody, and we'll see you again real soon. Bye-bye.